Okay, so we're going to look at a question from the 2021 higher level paper. It is a question on the sodium hypochlorite ion. So the first thing we want to do is just take a second to read through the actual question, and I've taken just the calculation parts from that question. There were procedural questions as well with this, but I'm just going to focus on the calculations. So take a moment to read through it. Okay, so the first question is to find the average number of moles of sodium thiosulfate used in one of the titrations. So we should have looked and seen our important parts in the question, so we can underline them. Okay, so we have two equations here. The first equation is to do with the equation that takes place in the conical flask. Okay. Okay, so that's the first one. So we have our bleach here. That's our iodine, potassium iodide we put in. This is the acid that we put in. That creates our brown iodine that we see within the flask at the start of our titration. Then down here is the equation for the actual titration reaction. So the iodine in the conical flask is titrated against the sodium thiosulfate that we have in the burette. So now that we've gone through that, we can focus on the first one. The average number of moles of sodium thiosulfate used up in one of the titrations. So it's not asking you for the amount or the molarity. It's asking you for the exact amount of moles in the 21.4. Sorry, I forgot to underline that part. This amount of the sodium thiosulfate. So we're given the molarity, we're given the exact amount used. So we want to find how many moles are in that 21.4 centimeters cubed. So to do that, we need to go and look at our calculations. So we have a formula for this. Number of moles equals the molarity times the volume over 1000. So the number of moles equals, the molarity there is 0.09, and we have a volume of 21.4 over 1000. So the 0.09 is how many moles would be in a litre. We don't have a litre, we have 21.4 centimetres cubed. So you can think of this little part as a fraction. So 0.09 times the 21.4 as a fraction of the litre. So I'm just going to write that in a different way if it makes it clearer. So the molarity times this as a fraction of a litre. They're the exact same thing. So whatever way you find easier to understand it, you can go write it down like that. Okay, so if you put that into your calculator, you should work out the number of moles of the sodium thiosulfate in that 21.4 sample should be 0.001926 moles in 21.4 centimeters cubed. And that's your answer to part 1. Now, part 2. The number of moles of iodine reduced in each titration. So it's the same type of question. we've already worked out how many moles of sodium thiosulfate there were. So if we look here, we have a ratio. 1 mole of iodine reacts with 2 moles of sodium thiosulfate. The amount of moles that actually reacted of the sodium thiosulfate we've already worked out over here. So that would represent the 2. To get how many moles of iodine, we'd half that, because the number of moles that reacted was 1 in terms of the ratio. So we need to take this and just divide it by 2 to get how many moles of iodine were present in that titration. And we should get 0.000963 moles of iodine. You can write this as terms of scientific notation if you prefer. Okay, that's our part 2 done. Part 3 is next. So I'm just going to wipe all of that out. And we'll focus on part 3. The molarity of the original bleach in terms of the hypochlorite ion. So the important part here to underline is the original bleach. So in the question, you can see up here, he says we've diluted it. So what we're going to work out now is, first of all, is the molarity of the diluted bleach. Then we have to look at the dilution factor to get the original bleach. So we're going to use our handy equation that we usually use. Part 3. First of all, we can figure out if we have enough information for it. Okay, so we can write everything down on the side. And see if we have everything. So the molarity of the oxidizing agent. The oxidizing agent would be the bleach. So take a look and if we have that or not. We don't. The volume of the oxidizing agent used, we do have that, so that's there, so we can write that in. The number for the oxidizing agent, so when there's 2 reactions, it's important to figure out if there's a certain ratio. So in the first one, the conical flask, 1 mole of the bleach gives 1 mole of iodine here. So 1 to 1. That iodine is then brought over here. So there's 1 mole of iodine still there. And that reacts with 2 moles of the sodium thiosulfate. Okay, so that's the ratio. That's very important to do because there is a question with a ratio that you have to multiply this by to make sure that it's accurate. So watch out for that. This one we don't have to do that. So I'll just make that a bit nicer looking. Take that away. Now, so we have number of oxidizing agent, which is here, down here. So that is 1. The molarity of the reducing agent we're given 0.09 moles. And the volume of the reducing agent we're given in the average titer, 21.4. Number of reducing agent is here, 2. So we're only missing one thing, so we can use our formula. So we just need to fill it in. Of diluted Okay, so we have all that done. We've got the molarity of the oxidizing agent now. So I'm going to rub this out over here so I have a bit of space. And we're going to look at the dilution factor now. So up here it says that 25 centimeters cubed was diluted to 500. So to work out the dilution factor, you simply see how many times it has been diluted. So you can take the final one, divide by the original amount used, and you'll get 20. That's the dilution factor. So that's how many times it's been diluted by. So the original bleach would be 20 times stronger in terms of concentration than the diluted one. So you're going to multiply that by 20. And when you do that, you will get 0.7704 moles per litre in original bleach. And that is the third part done. Okay, so we're on to the last section. So the concentration of the hypochlorite ion in the original bleach to the nearest whole number, expressed as a percentage weight per volume. So we worked out in the last one the molarity of the original bleach to be 0.7704 moles per litre for the original bleach. To get it in terms of a weight per volume, we need to get it in grams per litre. So we're going to convert that moles per litre to grams per litre for that ion. So you're going to look at it and you're going to find out the relative mass of each section. So that can be found on your periodic table. And what you're going to do now is add those together. So all together, that should give you 51.5 atomic mass units for that ion. Now, to get that molarity per litre in terms of grams per litre, you need to multiply it by its relative atomic mass to convert it. There we go, that's done. Now, when we're looking at weight per volume, the volume section is done in terms of 100 centimeters cubed always. So we don't have it in 100 centimeters cubed. There are 10 hundredths in a litre. So we're going to take that number 6 and divide it by 10 to get it into that 100 centimeter cube format. So we're literally just moving the decimal place 1 grams in 100 centimeters cubed. Okay, going off screen there a bit. Now, so we want to get it as a percentage into the whole number. So it's important to read the question and underline everything that's important. So if I round that to a whole number, it's going to be 4 grams per 100 centimeters cubed. And we want it as a percentage now. So you can literally just write 4% weight per volume in the original bleach. Okay, so that means that there's 4% of that active ingredient, the hypochlorite ion, present in the original bleach. And that's that question completed.